Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today we are going through a series of questions that was on a midterm, and we're reviewing them for one of my students. This is the second question, and the second question involves some facts from trigonometry, dealing with inverse trig functions and unit circle ideas, and we want to cover those because they come in handy when we're dealing with some integral and derivative problems. So first thing we're looking at here is finding the arctangent of the tangent of 5 pi over 6. Now, first glance, it may look like, hey, aren't arctangent, isn't that the inverse function of tangent? Can't those two just cancel like this? And we just end up getting 5 pi over 6? And the problem is that the arctangent function is limited in its range. And the two functions don't cancel each other out necessarily. They can't. So we have to work within the range of arctangent. So what do I mean by that? I mean that arctangent's range is between negative pi over 2 and pi over 2. And the answer, the values that we get out of arctangent have to be between those two. And 5 pi over 6 is just too big. It's bigger than pi over 2. So let's write down the range here and let's talk about how we can do this problem. So when you're dealing with a trig function and its inverse trig function, the two together, you want to start from the inside and work your way outwards like we would normally do. So the tangent of 5 pi over 6, if we remember your unit circle, that's equal to negative rad 3 over 3. And even if we look at a unit circle, that should make sense. That's going to be the y over x value over close towards the negative x-axis. So I'm going to draw up a quick coordinate plane here. And so right now what we're looking at for 5 pi over 6 is somewhere right over here. So that right there is 5 pi over 6. So now when we look at the arctangent of tangent of 5 pi over 6, which is now negative rad 3 over 3, what we have to ask is where between negative pi over 2 and positive pi over 2 is tangent also negative rad 3 over 3. And so what we can do is we can actually just flip this line over here and go right to there like that. That line right there, that angle coming backwards, coming this way, will also have the same tangent. So the tangent of, and this is going to be negative pi over 6, the tangent of negative pi over 6 is negative rad 3 over 3. And that angle is between negative pi over 2. And so the arctangent of negative rad 3 over 3 is negative pi over 6. And that's something nice. You can kind of take that to the bank. You can say, well, anytime I get the arctangent of negative rad 3 over 3, it's always going to be negative pi over 6, regardless of the original angle given to tangent. All right, so now the next one, a little bit interesting. We've got the arc sine of x, and we're taking the cosine of that. So what we want to do with this one is start off with the inside, just like we did with the last one, and recognize that anything that's inside of a trig function is an angle. So what I can say is that the arc sine of x is equal to an angle, and let's call that angle theta, because that's usually what we do. So now using the property of inverse functions, we can pass arc sine over to the other side by using the actual sine function. I'm do this carefully, but this is basically what we get. So that x is equal to the sine of theta. Okay, so now we've got something that we can deal with here. So here's the trick. Here's the thing that you've got to know going into a problem like this. sine of theta equaling x is actually equal to x over 1. And I want to write it like that because I know it's coming up next, but because sine in a right triangle is the ratio of the opposite side of theta over the hypotenuse of theta, or the hypotenuse of the triangle. So now if I get out a right triangle here, I can know what the sides are because I know what the relationship between the opposite and the hypotenuse is, and I also have the Pythagorean theorem. So let's call this theta right here. And then the sine tells us that the opposite is x and the hypotenuse is 1. So then if we call this side b down here, and we use the Pythagorean theorem where x squared plus b squared is equal to 1 squared, or just 1, b squared then is equal to 1 minus x squared. And so that makes b the square root of 1 minus x squared. We'll take the positive root on that because it doesn't necessarily make sense to take the negative one. So cosine of the arcsine of x now, well, arcsine of x is just theta. So this is the cosine of theta. And cosine is the ratio of the adjacent side over the hypotenuse. So this is the square root of 1 minus x squared over 1, or just square root of 1 minus x squared. So that's it. That's the answer for both of those. Thanks for watching, and I'll see you in the next video.